Astrobuds, here's our 5-second. We got 20 stacks and 1 ignored views of Messier 110 to kick off this evening, 7:31 on the 29th of October 2025. It is a Wednesday night. I have decided because of the moon that I am going to do 5-second exposures and make sure we get plenty of stacks. And we're going to revisit NGC1, 2, 3, and 4 to get a sense of the views. This is our 60x view. This is our nominal 90x view. Looks very nice to me on the screen. The extensions aren't as obvious. They're very subtle. And that's one of the characteristics of working with trying to balance aesthetics versus presence. Let's go ahead and push it up a little bit. I just slid the left slider over. It didn't seem to improve the presence on the screen. Now I'm going to push the right slider way over. It got very dark. I'm going to go to the point where it just starts to touch the screen, and we shall leave it at that. Let's have a look at 31, 32, and then launch into our NGC studies for the evening. Okay, I'm going to monitor the stacks. We've got 2 now on a very brilliant Messier 31. And we've got 3. Let's push it up. 6 stacks is the norm. I've discovered that the REV2 system will take it 6 stacks anyway, even if they do not line up. There's no triangulation algorithm. It was a very inexpensive system, and we should not expect otherwise out of it. Here's our 90x view. We have 6 stacks. None have been ignored. I have done a model, and I've kept everything under 2,000 stepper counts, which I now believe is about 0.3 to 0.5 arc seconds per stepper count. I had to come off my error value because it was causing all kinds of craziness with the models. So I had to go back to the normal side reel settings of the Losman D Gemini 2 mount. Okay, folks, let's start with this. I never, ever, ever got an image as good of Messier 31 with the REV2 system. I will try to find and grab a screen cap, but you will see it's pretty abominable. This is a 5-second exposure, which is basically twice the REV2, but it only adds 0.8 arc minutes to depth, adds about half of the aperture over again. So if the REV2 is operating at about 16 to 18-inch aperture, the 5-second exposure should be roughly equivalent, if everything else is the same, of a 24-inch telescope. And we are definitely seeing all kinds of texture and banding, etc., in Messier 31. Which suggests to me that, yes, indeed, 5 seconds of exposure is probably somewhere in the 24-inch aperture range, which means galaxies to magnitude 16 visual should be feasible on a really good night of seeing. Unfortunately, we're now entered into the second quarter of the moon. The sky is really clear, though, going into the evening. I'm going to once again adjust the histogram just using Messier 31 before we launch into NGC1 for the beginning of the evening's re-exploration to see how things map up against the REV2 and the digital sky survey images on theskylive.com. Well, here's where I ended up on the histogram. I can adjust it using Movie Maker if this isn't that good, but look at all the beautiful texture in Messier 31. The great Andromeda Galaxy, which I have to point out, is probably more massive than our own and will probably be 60% of any galaxy that's formed in about 3 to 4 billion years when both Milky Way and Messier 31, the Great Andromeda Galaxy, do their spiral dance and tango into each other. All right, we've got 4 stacks now, none ignored on NGC1, a galaxy in Pegasus, and its neighbor NGC2. Pushing it up to 90x and centering them in the field, it's pretty clear that we can see the core of this 12.8 magnitude galaxy and its orientation, and we get a sense of orientation of magnitude 14.2 visual NGC2. I'm going to go ahead and play with the histogram just a little bit because it changed after we visited with Messier 31. And by running the right histogram slider down to the point of conjunction of the spectral spread, we are getting a very fine view of both galaxies, extensions on 12.8 magnitude NGC1 and extensions on 12.8 magnitude NGC1 and extensions on the fainter, less developed NGC2. Fine views, 5 seconds, twice that of the REV2 system, and I have decided to stay with this approach because otherwise anything less than 5 seconds you just cannot get stacks because they do not triangulate. And the REV2 system was stacking anyway, even though it was making stars look very unpleasant. Okay, what we really have to deal with here is apparently there's so few stars in Pisces that are visible against the bright background sky that we cannot find any matched triangles. So we're not getting any stacks. And without stacks, we are not really going to not be able to dim out this background sky enough so that 15.9 magnitude galaxy NGC4, which is located right about here, is never going to distinctly reveal itself to us. However, it is kind of hinting at it. So what I'm going to do now is I'm going to push up the exposure time and find out at what point we can get matched triangles and that view of magnitude visual 15.9 NGC4 becomes possible. Okay, now at 10 seconds exposure, we've got 2 stacks with 1 ignored, so it's kind of on the fringes here. We'll go to, let's see if we can get to 6 stacks. 3 stacks, so it looks like when we go to 10-second exposure, we start stacking. Here's our NGC3. NGC4 is this galaxy here. I've already really mapped it out using Digital Sky Survey. This is a faint icy galaxy, which I estimated being magnitude 16. And these are a pair of NGC galaxies down here. I'll have to map them out. There's another NGC galaxy here, and I believe one right here. They're all part of the NGC3 galaxy group. Now, what I'm going to do is play with the histogram and see if we can't balance out a little bit more. Yes, we brought things out by moving the left histogram slider. Not only have we brought it out, we're seeing more detail in terms of all the galaxies involved. Now, these galaxies here, 3 and 4, are at the beginning of the NGC catalog. This IC galaxy here, I suspect, is not part of the catalog. These 2 galaxies here are now beginning to pop. There's another faint galaxy right here and here. All of these galaxies have average brightnesses in the 14 to 14.5 range, which means basically it would take a, let's see if I could figure this out, 16, 12, 13.5, 15. Yeah, it would take about a 30-inch scope to reveal all of these galaxies to the detail that we are currently seeing. In particular, this faint IC galaxy, which I haven't not been able to identify, but this baby here at magnitude 15.9 is a real difficult study to pick out at the eyepiece. I will give you Steve Gottlieb's. I will give you Steve Gottlieb's observations on these, but this is also going to be folded into another video I'm working on where I compare REVII, ZWO, and DSS Images in order to get a better sense of what we can see using a 6-inch scope with real-time imaging. Okay, the ASI Live software is reporting 3 stacked images at 30 seconds each. Let me verify that. Yes, indeed. We will go and add more pixels to the mix and try to capture all the galaxies of interest in the NGC3 galaxy group. 3, 4, this faint IC galaxy. These are all 78, 36, I believe, through 40, maybe not 40, 30, 39. I will detail them out. This one is looking quite diffuse. This probably IC galaxy. Very tight here. We're getting very fine extensions now on 12.8 magnitude NGC3. Getting some extensions here on these other NGC galaxies. This one here looks face on. Fairly immature, no star-like core, fading out to all directions. This is a very fine view, and let's push it one more time. Okay, I have to remind myself not to stop the stack when we're looking at the same study consistently, because now I'm going to have to wait 60 seconds before the first image comes up. Now, I want to point out also at the bottom of the screen, it's saying we already got one stacked image. So it's basically using one of the earlier images, however, with the histogram setting at a point where it's not revealing much of the sky whatsoever. This is a 9th magnitude star. This one here is probably 11th. It's probably as faint as a 13th magnitude star somewhere on this screen. So until we get our 60 seconds in, we're not going to be seeing anything of those galaxies. Okay, we now have our first stacked image at 60 seconds. Galaxies are popping with extensions, and some, I would call it class 1 is being able to find it. Class 2 is seeing the core. Class 3 is seeing the core with extensions. I would say class 5 would be seeing some kind of texture in a galaxy. And class 6 would be seeing like an annularity, or in a 7 class, I'm just making this up on the fly, folks, would actually be able to see something like a globular cluster, H2 region, etc., within a galaxy, some real texture. And the only galaxy I know of who really can do that easily is Messier 31. Okay, we've got 3 stacks now. Of course, it counted the first stack at a lower exposure time to begin with. So anyway, I'm going to adjust the histogram a little bit and bring things out. 3 stacks is quite good at 60 seconds exposure. We're not seeing any comatose stars. The focus must be really good. Lots of features of these galaxies. You can tell what their extensions are, you could probably determine their class if you're familiar with them. We've got this 15.9 galaxy here, this lower average surface brightness IC galaxy here. I'll try to find out what its identity is. We've got these 2 NGCs in the 74, 37, 35, 40, 35, 36, 37 series here. Nice face on, mounting to a bright core down here associated with these 2 stars. Another edge-on galaxy there. We just completed another pass. 6 passes is really all you really need to really get a good view of studies. And we are now, like I said, we are operating at 60 seconds. We're 13 and a half minutes into this video. I think we can try to shoot for 1.5 minute exposures before we go ahead and sign off Carpe Noctem out for the evening. So let me pause this. Oh, let's do some magnification, because we need at least 150x to really begin to really pop any kind of details. But unfortunately, we are getting stars are not looking that precise. Although I did set the focus on the moon earlier, these are some very interesting views of the various galaxies. I am very pleased with the galaxy views, but the aesthetics falls apart at 150x. Let's drop it down. At 40%, things are improving somewhat. I could play with the histogram once again. Well, that makes it really too dark. So let's filter out a little bit more of the background light. There we go. I'll make another tour of the galaxies. NGC3, NGC4, some kind of faint IC galaxy, a couple of NGC 83, 84, 37, etc., etc. Some nice views there. All right, let's go ahead now and see if we're tracking well enough, because I had to revert to the normal sidereal settings in order to get a good model. I could not use the RA value that I had input for better tracking. Let's see if we can still track at 2 minutes exposure time. Well, I gave it a try. We're not getting any, even within the image itself, there's distortion going on. We've only got one image and stack, and we're not quite cutting it at 120 seconds. Without that RA divisor being set up, it doesn't look like there's much hope of doing 120-second views. However, I did step off the observatory, and it's possible that I upset things a little bit, but I tried to be as stable as possible when I got back and I reinitialized the stack. So we're going to go back to 60-second exposure for our Carpe Noctem view, and let's have a good look at Messier 110. Well, aside for the streakage, which are very parallel in their motion, and I can't account for that on the part of the motion of the scope because I didn't initialize the stack until after it had stabilized. This is a really stupendous image of Messier 110 in its full extension. What I'm going to do now is I'm going to zoom in, center it up, to give you a view of what it's like at, let's do 100% pixelation. So this is what the galaxy looks like when, oh, we have 3 stacks on this, very nice, when we're operating at 100% brightness of the E-zoom setting. E-zoom equals 100% means all pixels recording, and every one of these little dots is a little imaging pixel that is presented to the screen, and therefore it is brighter than it otherwise would be. But look at those stars, quite ugly. If we go back to 80%, we're now at the point where the scope is able to actually resolve, if the imager was capable of it, should be able to resolve down to 0.8 arc seconds if sky conditions permitted and there wasn't so much light being presented onto the screen. Typically, you have to have fairly faint stars to resolve them down to 0.8 arc seconds, which is the limiting of this scope. 3 stacks now, none ignored. Now, if we go back down to 50%, this is probably as much as I usually like to push it when I'm imaging, because the stars start to look a little bit more reasonable, but they still don't look anything like they would look in the eyepiece. So let's back off to 40%. The view is improving, and 30% is going to be my normative view because it just fills the field of view at 90x. Look at this nice heart-shaped group of bright stars. Don't you just love Messier 110 at 60-second exposures, stacked 4 times with some kind of weird streaks blowing past it. And with that, I am going to say, after our 5th stack, and you can anticipate it, we're now 18 minutes and almost 30 seconds into this video total time. The time is 8:07 p.m. The sun set before 6 o'clock this evening. And with that last 5th stack with none ignored and a total exposure time of 300 seconds, I'm going to say, carpe noctem.